Okay, here the cast method is cos, C for cos, A for all, S for sine, T for tan. First of all, why do you need a cast method? If you want to find angles in T ratios greater than 90 degrees, we need the cast method. Okay, so first is your why. Why do you need it? To find angles greater than 90 degrees. Okay, we need cast method. I'll take one example and I'll tell you. It's very easy. You just have to do two checks. Okay, two checks. So let me tell you. The two checks are, the first one is called sign check. Sign means whether your sign will be positive or negative. Second, T ratio changes or not. Okay, understand it very simply, will not make it complicated. Now let's take an example. Imagine you have to find the value of cos 200 and let's say 10 degrees, right?
Yeah.
You don't know, we only know values for 0, 30, 60, 90. That's it. And nowadays you have calculators, so people don't even use that, but we should know. So what do we do? The first thing we do is you will break your angle, which is your theta, into 180 plus 30 degrees. Now how do you break it? You can break into 90 plus, I'm going to call this alpha. Okay, this angle, what this is our alpha. Or you can break it into 180 plus minus alpha, or 270 plus minus alpha, or
But why is it only 90 plus and not 90 plus minus?
if you do
Oh, because
minus.
it only has to be above 90 as well.
Exactly,
Okay, I got it.
exactly. So if it's minus, why do you need to break it? You don't need it for greater than 90 degrees. Okay.
Yeah.
So these are the possibilities in which an angle could be broken. Remember, alpha has to be an acute angle. It cannot be greater than 90 degrees. Okay.
Yeah.
There are two ways. I'll show you both. One is I can break it into 180 plus 30, and I can also break this into, hold on. Okay, so this is one. I'll tell you the other one as well, which is, and parallelly, let's break it into cos 210 can be written as what? 270 minus 60 also.
Yeah.
Okay,
But either way, you get the same results.
yes, I'm showing it because you get the result same from both of them. So first let's do one. First job is break your angle greater than 90 degrees into any of these four forms. Okay, remember 1, 2, 3, 4, and the condition is alpha should be acute angle. Clear?
Yeah.
Second, now we'll come to, so now we'll check whether the sign will be positive or negative. How will you decide? Very easy. If your angle and your T ratio belong to the same quadrant, then it's a plus, else it's a minus. Very easy. Okay? Repeating again. Now check, your angle is 210 degrees. It belongs in which quadrant? Third?
If third and fourth.
No, why fourth? Just
Oh,
one.
sorry. Third and
210
wait.
degrees. Hold on.
Yeah.
Let's go slow. This quadrant is comprised of which values? 180 to 270.
Yeah.
Correct? So 210 falls in which quadrant? Third quadrant. Correct?
Yep.
Now, does your cos also belongs to the third quadrant? No.
No.
There is a mismatch. Hence, the sign will be minus. Simple. Okay? If it matches, then it's a positive, else there is a minus. Any doubts? This is your check 1. Any doubts?
No.
Second, T ratio changes or not? T ratio will change if you have T ratio will change if you have 90 plus alpha or 270 plus minus alpha. In these two conditions, T ratio changes. But if T ratio or your angle has been broken into 180 plus minus alpha or 360 minus alpha, which is even, okay, if it is even, no change. If it is odd, you change. Change to what? Sine goes to cos and vice versa. Okay, tan becomes cot and vice versa. Theta is not needed, just say. And sec becomes cosec and vice versa. Okay, now the reason I generally prefer to change in 180 or 360 is if possible, because we don't have to worry about the T ratio. T ratio will not change. Why? Because it's even. So when it's even, you do not change, no changes. Okay, even, no changes. So because it's even and we are not changing, so my cos will remain as a cos. It's not going to change, and I'm just going to copy this alpha down. So the value is minus root 3 over 2. Done. That's it. Okay, clear? It will take some time for you to get used to it,
I
but it's very easy. Once you get a hold of it, you hardly need 30 seconds to decide what is the angle. Now let's also use this. I'm using an odd angle now. Okay, I can express any of the four. I choose to express it 210 as 270 minus 60, which is still equals to 210 degrees. Correct? Let's do the same check. This will again remain the same, so sine will be negative because my cos belongs to fourth quadrant, but my angle belongs to third quadrant. There is no match, so negative. Okay. Now next check is my T ratio going to change or not? So because it is an odd angle 270, right? We will change this cos into which T ratio? Cos will become sine, sine becomes cos, vice versa. Because we have cos, we will change it into sine. So we get sine, copy the 60 degree value. Still you get the same value, no changes.
Just one thing. How do you know when to change from cos to sine, tan to cotangent, whatever? Like,
Look at
where does
this.
the change come again?
This is 270. The
Yeah.
angle is odd. So this is odd, correct?
Yeah.
When it is odd, when you are representing it as 90 plus or 270 plus or minus, whatever, your T ratio will change. That is what I have mentioned over here. See, 90 plus minus or 270. This is what is mean by odd. Odd means 90 and 270 are odd numbers, no? I mean,
Yeah.
technically it's 0, but 9 and 27. So call it odd angles. Okay. And since we had even over here, this is even 180. So we are not changing the T ratio. Cos remains as cos.
Okay, I got
Because
it.
it's a 270, cos will now become sine. So there is a change. Understood?
Okay.
This is
So
your
the number on the left is just used to determine whether you change the ratio, and then the number on the right is like what you actually sort of put with the function.
call it alpha. Alpha is your acute.
Alpha. Okay. Okay, got it, sir.
What you get is your theta. You need to break your theta into any of these forms plus alpha.
Okay, sir.
Okay, so theta will change into any of these forms.
Okay.
Okay, practice this. You will still have doubts, not that you will get it, but it's good to know.
Okay, sir.
Now, hold on, let me stop this.